Welcome back to 5-Minute Photo. I'm Bill Ferris, and in this episode, we're going to take a closer look at a technological advancement that has changed digital imaging significantly, and for the better. In the Nikon universe, it's referred to as vibration reduction. In Canon parlance, it's called image stabilization. In other worlds, it's referred to as vibration compensation. However you say it, the ability of modern lenses and cameras to compensate for the inherent shakiness of hand holding your camera to make a photograph has been a significant and positive development in the art form of digital imaging. To take a closer look at this and to better understand it, I decided to set up a test. I used my Nikon D610 camera and a Tamron 70-200 zoom lens to make a series of photographs. Now, these photographs ranged in exposure length from 1/100th of a second to 1/2000th of a second. And I made at least 2 sets at each of these exposure lengths. In one set, the vibration compensation of the Tamron lens was activated and working. And in the second set, the vibration compensation was deactivated. It was turned off. The objective here was to have a set of photos to compare that would allow me to see how well the vibration compensation worked in removing shakiness or unsteadiness in the handheld image, and to have a second set of images that would have the inherent shakiness of my handhold fully on display. So let's go into Lightroom and start taking a look at the photographs. So I've imported all the images into Lightroom, and I'm using Lightroom's metadata filter to filter the images in the catalog by certain qualities or parameters. First of all, they're all images that were taken today, October 18th, with the Nikon D610 camera and the Tamron 70-200 zoom lens. The final filtering criteria I'm using is shutter speed. And so we will take a look first at all the exposures that were made at 1/100th of a second. There are 4 images, and those that are labeled or highlighted in yellow were taken with vibration compensation turned on. The exposures made that are highlighted green were made with vibration compensation turned off. And so let's start comparing. These are the first 2 images. Let's select vibration compensation on and off, and we'll go down to the XY compare view tool. I have this set up so that we're looking at a 100% view. So we're seeing the full resolution of the image. And as you can see, I think looking at the outline of the letters, I'm seeing a bit of advantage for the image with vibration compensation turned on. So we'll go back to the 4-image view. Now, I did repeat this series just so I wouldn't be limiting myself to one set of exposures at each exposure length. So we'll select the second set. We'll go into the comparison view there. And I think the advantage of vibration compensation is even a little more obvious. So let's go back to the 4-image view, and let's just select the 2 handheld images. Let's compare them. And yeah, this one on the left, I think my handhold was a bit steadier than the one on the right. So we'll go back to the 4-image view. Let's take a look at the images made at 1/200th of a second. We'll start going a little more quickly through these. Here are the first 2 images made at 1/200th of a second exposure. Vibration compensation on the left, looking pretty sharp. Handheld, no compensation at all on the right. Clearly not as sharp an image. We'll go back and let's compare the second set of images. Vibration compensation on the left, no vibration compensation on the right, and the image on the left is looking fairly sharp. I think, again, the one on the right is just a bit softer. And again, let's do that comparison. Let's take a look at the 2 handheld images, and we'll compare them. just to see if one looks obviously better. The one on the right might have a slight advantage. Let's compare the two images made with vibration compensation turned on and see if there's some consistency there. And I will say, the image on the left to my eye might be a little bit sharper. The exposure is slightly different in both the images, but they're definitely both sharper than the two handheld images. Okay, 1/400th of a second was the next step in exposure length. You notice we're getting faster in the exposure lengths. We'll compare the first two images. Again, vibration compensation on the left, handheld on the right, and again, an advantage for vibration compensation, which is exactly what we would expect. One of my goals, however, in making this test, and let's move on to 1/800th of a second, was I wanted to see if there is an exposure that is so quick, so fast, that whether you have vibration compensation on or off is irrelevant. It doesn't make a difference. And here's what I'm trying to get at. If I make an exposure at 1/2000th or 1/4000th of a second, is the exposure so fast that even though my handhold is not stable, not as steady as a tripod, will that quickness of the exposure essentially eliminate any shakiness and result in a crisp image as long as it's in focus? And one way of testing that would be to see, well, does vibration compensation make the image any sharper? Does it still have benefits at such fast or short exposures? Anyway, here we are at 1/800th of a second comparing the first two exposures made at 1/800th of a second. The interesting thing to me here is handheld on the right, I think, is looking less sharp than some of the longer exposures. The image with vibration compensation is looking very good. Let's take a look at the second set of images and compare them. And again, vibration compensation is looking great. Now here's one where handheld is really holding up quite well at 1/800th of a second, which is what you'd expect. You should be able to take a sharp in-focus image at that kind of exposure length with a 200 millimeter shot. And all of these images were made at 200 millimeters. Go back to the catalog and we'll scroll down. Let's take a look at 1/1000th of a second. Here are the first two images at 1/1000th of a second. And vibration compensation on the left, handheld on the right. Vibration compensation is not looking as sharp in this image as it has in the earlier images, but it's still sharper, I think, by a little bit than the handheld image. And we'll go take a look at the second set of images. Here, vibration compensation shot is very sharp, and the handheld shot is really quite good as well. Although, again, I think I'm still seeing an advantage, a little sharper image over here on the left than on the right. 1/1250th of a second. Here are the first two images. And scroll down a little bit so we can see a bit more in the way of letters. And vibration compensation on the left versus the right. The vibration compensation has an advantage at 1/1250th of a second. Let's take a look at the second two images made. We will compare those. And here is an obvious advantage. Vibration compensation on the left is just much sharper than the handheld image on the right. 1/1600th of a second. First two images, vibration compensation is here on the left, handheld is on the right, and I'm still seeing an advantage with the vibration compensation even at 1/1600th of a second. Let's take a look at the next two exposures. Vibration compensation looks even better there, and significantly better than handheld at 1/1600th of a second. Let's look at 1/2000th of a second. Again, the first two images. And while handheld is holding up quite well, this is a very good image, and it's better than some of the images made with vibration compensation engaged at shorter exposures, but you can still see a difference, an improvement in the image with vibration compensation on the left. Let's take a look at the second two images. Compare them, and again we're seeing the same thing. Vibration compensation on the left is much sharper than handheld on the right. We'll go to 1/2000th of a second, comparing the first two images. And I'm sure this handheld image would be extremely usable, but I still have to say, vibration compensation is giving us an advantage over the handheld image. It's just a little bit crisper, a little better defined along the edges than the photograph that was taken strictly handheld. Let's compare the second set of images to see if that result holds. And this is probably the closest we've had in terms of result, but you'll see this image with vibration compensation. It's just as sharp, just as crisp as the first that we looked at. The handheld image, I think, is pretty much a match. Probably the equivalent. There might be a slight advantage in vibration compensation, but we might be picking nits in saying that. Now, I did make exposures at other exposure lengths just to see what the results would be. So let's go into Lightroom and take a look at those. At 1/25th of a second, I just made one set of exposures here. Let's compare them. Vibration compensation on the left, handheld on the right. You can see the obvious difference. The handheld image would not be at all usable under any circumstances. The image with vibration compensation, if we zoom out to fit this image on the screen, this is, I think, like that first handheld image that we looked at 1/100th of a second exposure. This could be a usable image at 1/25th of a second with a lens that's set at a 200 millimeter focal length. That's significant. That's saying something. Let's take a look at the 1/40th of a second exposures. Now here we'll notice something a little bit different. I have on the left, this image was made handheld with no vibration compensation. On the right is where we find the image with vibration compensation. So let's compare those two. Again, this is a change on the left. Here's handheld without compensation. On the right, the vibration compensation is engaged. And again, if we zoom out to the fit on the screen view, this image is very usable, even handheld at 1/40th of a second with the lens at 200 millimeter focal length. This photograph, it's all right. It's definitely not as sharp. You can see it's very rough around the edges. But let's go down to 1/4000th of a second. And again, I just made one set of exposures. Vibration compensation was active in the image on the left. The image on the right was made strictly handheld. Let us compare the two. And very crisp here. And an advantage over the handheld image. An advantage in vibration compensation at 1/4000th of a second versus a handheld image at 1/4000th of a second. Now, I have read and seen photographers online who have recommended against using vibration compensation when making very fast exposures. And typically the cutoff range is somewhere in that 1/1000th of a second to 1/1600th of a second exposure. When taking exposures that are that fast, that short, the recommendation is not to use vibration compensation, and the reasoning is often twofold. One, the belief is that vibration compensation does not add any benefit at such a fast exposure. Or two, the thinking is that vibration compensation may introduce blur or degrade an image when it's engaged for very fast exposures. However, that is not what we're seeing here. In these test images made from a range of exposure lengths from 1/100th of a second to 1/2000th of a second, with two sets of exposures made at each of those lengths, in one set, vibration compensation being active and engaged, and in a second set, vibration compensation being deactivated, what we're seeing is a consistent result in that the images made with vibration compensation activated show noticeably sharper detail, noticeably better detail in comparison to those photographs made at the same exposure length but strictly handheld. Even in the exposures at 1/4000th of a second, where we just made one exposure with vibration compensation active and one with VC deactivated, we saw the same result. The image with vibration compensation active was just slightly sharper than the image that was strictly handheld. And so based on these results, my recommendation would be that you at least consider leaving vibration compensation engaged whenever shooting handheld, regardless of the length of the exposure, no matter how fast. There's no indication that it introduces blur, and there's consistent indication based on these test images that vibration compensation can result in a sharper, a better image. Now, perhaps you've done similar tests yourself and have had different results in your test images. If so, I would encourage you to please share your comment on my YouTube page. Look forward to hearing from anyone who has done similar tests with vibration compensation to see where the cutoff is and what the degree of benefit is when using this relatively new and extremely beneficial technology in digital imaging. Thank you for watching. I'm Bill Ferris, and I'll see you next time on 5 Minute Photo.